Okay, so hi everybody. My name is Steve Zelek, and I'm here tonight to give a talk on Stencil JS and how you can use Stencil JS to write component libraries that are framework free. But real quick, before I get started, I want to know a little bit about everybody here, just so I understand what everybody's level of familiarity is with front-end development. So I'm going to ask a few questions. I'm just going to ask people to raise their hands. Okay, so first, how many people here spend at least some of their time at work working on a front-end project? Raise your hands. How many people spend most of your time working on a front-end project? Okay, all right, good. How many people here use TypeScript? Okay. How many people here use Angular? Okay, React? Or some other framework? Ask them about that later. All right. So part one, me. I just want to tell you guys just a little bit about myself so you know who I am. I've been programming since I was a teenager. I went to school for computer science and I graduated a few years ago and then started working at Chatham Financial as a full stack developer. I've been at the company for going on 3 years and I've delivered a few projects. I tend to specialize in front-end development, and on my team, I'm one of the main front-end experts. At Chatham, I'm also a big part of a group that we have called the Front-End Guild, and that kind of is going to lead me to our topic for tonight. So in the Front-End Guild, we are a group of interested developers at Chatham who mostly focus on front-end technologies and want to think about how we can move the state of development further in the front end. One of the biggest initiatives we have in the Front-End Guild is called the Pattern Library. So the Pattern Library is an idea that was created at Chatham in order to solve a pretty specific problem. Since Chatham has a really wide product offering, we have dozens of different applications that are all separate projects but all live in the same place. So you might be jumping between different projects all the time as a user. So we don't want that to be a jarring experience visually. We want it to kind of look similar, as similar as possible at least, so that as you're going through these different tabs, different applications, different tools, it's a cohesive experience. So in order to ensure that our applications have similar UIs, the design team at Chatham got together and made some decisions about how everything should look. What should a button look like? What should an icon look like? So once a unified standard was agreed on, it was time to see if we could actually take that standard and turn it into code. So there's a CSS library that was created called the Pattern Library, and it's really widely used at Chatham. But we want more than just CSS. CSS is useful, but it's not everything. We want behavior too. We want JavaScript. So we want fully functional components that we can reuse across these different projects. So another library was created in order to actually implement the JavaScript side of everything. And since Angular is the most popular framework at Chatham, we ended up with the Angular Pattern Library. And we all lived happily ever after. Or not. Because if that was true, that would be the end of my talk, and I would just tell you all to build a CSS library and use Angular, and you'd be done. But that's not the end of my talk, so what is the problem? So I want to talk about two main things that have been big problems in our approach to creating a good component library with that previous strategy. The two big problems are frameworks and versioning. So there's a lot of really popular frameworks for front-end development, to put it lightly. And frameworks are starting to specialize. So they're not always about what's the best framework. It's more like what's the best framework for what I need. You can take a look at this chart from the 2018 State of JavaScript survey. And we can see here that React has won a lot of hearts and minds. Vue actually is the framework that the most people have heard of and want to learn. And you can see that in Angular, there's this big pink block of people who used it but would not use again. Which means, and those people might quit front-end development, or they might use a different framework. So most likely what we would see is a lot of that percentage of people who are using Angular migrating to different frameworks. React, maybe, and if so, maybe it would just all be React, but probably not. So probably it's just going to keep spreading out, and there's always going to be different frameworks that solve different problems. So meanwhile, back at Chatham, like I said, we had the Angular pattern library. We also had another implementation in the works called the React pattern library. And once we got to that point, we started to say, hold on, what are we doing here? Are we going to write 3 more pattern libraries, one in Vue and one in Ember, one in Polymer? And hey, I mean, Angular is the most popular framework at Chatham, so why do we even need these frameworks? But times change. So like I said, there was that big pink block of people who don't want to use Angular anymore. And you can see over time how the trends have shifted, right? So at the beginning, Angular looked a lot more like Vue did, where not that many people had used it, but a lot of people wanted to. But over time, you can see a lot of people have used it, don't really want to use it. There's less people who want to learn it. And when there's a technology that has less people that want to learn it, that means that over time, there's going to be less people who know how to use it. So maybe Angular isn't the end-all be-all. It's not becoming some kind of ultimate framework, and in 5 years, it might even be unpopular. So we have to ask ourselves a really important question. If we want to, can we actually change? What will it cost us? We have to examine the burdens on innovation that are incurred by that current idea of using an Angular pattern library, right? So one bad situation is obvious. We know for sure that if we did change frameworks, then we couldn't use the Angular pattern library. If we're using React, can't use the Angular pattern library. But there's actually a worst case. What if, because we have the Angular pattern library, we just never try another framework because it's comfortable? And even if we did change, we'd then have to rebuild maybe the React pattern library. And then we're stuck with really the same situation. What if the framework changes again? Are we going to do this every couple of years? It's not sustainable. So that's the first problem, frameworks, right? So if we want a reusable component library, frameworks are a huge hurdle because the code we write has to be compatible with different frameworks. So the second problem I want to talk about is versioning. So I ran some numbers, and I was looking at the Angular pattern library at Chatham, and right now the Angular pattern library is used by 30 different projects inside Chatham, which is great. It's being used a lot. But the problem is that the consumers using the library are actually using 18 different versions of it, and only 3 are using the latest major version, which means that our solution is not actually even solving the problem that it was created for, which is making sure that every app is up to date in terms of the styles. And it's effortless to have the latest styles for every application so that it's a seamless user experience. So right now, if we had new changes to the library, only 3 apps would even get those changes. So what went wrong? Well, I just want you to take a moment to meditate on this quote. So that code is legacy code as soon as it's written. It's kind of a joke in programming, but it's often true. So if we want all 30 projects to get the latest changes from the Angular pattern library, what do we need to do? Well, the library is an NPM package, so when we publish a new version of the library, every consumer needs to go update their package.json, put in the newest version, do an NPM install, rebuild the project, and then redeploy it as a new version. So it's a compile time dependency. It's a build time dependency. So in short, every single of those 30 projects that are using it need to be updated. But that's actually not necessarily the worst thing. One of the bigger problems is that if we actually use a new major version of Angular in the Angular pattern library, then the consumer would also need to update their version of Angular. So not only would they have to update the Angular pattern library, which is minor but annoying, they might have to actually update their version of Angular, which is maybe possible, but probably not. Because you'd have to have 3 things be true. The Angular version would have to not break too many things. Someone would have to be currently working on that project, which is not guaranteed. And it would have to have good tests so that you could actually make those changes with confidence. And then remember that quote from a minute ago, code is legacy code as soon as it's written, right? So if we want to actually accomplish our goal of keeping every project up to date, this is just not a good model for success. It has too much emphasis on maintenance. It's difficult to actually follow through and use. Things that are currently being worked on will be up to date, which they would be no matter what. And things that are not currently being worked on will not be up to date. So projects will start to fall behind. And as major versions come out of the Angular pattern library, things that were on a previous major version wouldn't even get our minor version changes. And here's another problem. So what if I'm working on a project that uses the Angular pattern library and I want to update my version of Angular? Well, there might not be a version of Angular for the Angular pattern library yet that's compatible there. So now, if I'm on Angular 7, I want to go to 8, but the Angular pattern library is on 7, I can't actually go to 8 because it's still on 7. So now the library that's supposed to be helping me is actually a blocker for updating my project. So you can see that in two ways the versioning is a huge issue for a reusable component library. So now that we're kind of clear about the problem, I want to finally talk about the solution, and you can probably guess what I'm going to talk about because it's the title of my talk. So in June of this year, the first fully fledged version 1 of Stencil went live, and we recently got a chance at Chatham to get some hands-on experience, and we like it a lot. It's already being used by a lot of big players in the web development space, such as Amazon and Microsoft. And so let me explain what Stencil is. So Stencil is a tool that was developed by the Ionic team. They're really famous for creating this Ionic framework that was basically called Bootstrap for mobile. And so it was a set of reusable components that you could use on mobile devices, and it became really popular. Stencil is a compiler they created that lets you generate web components. And it lets you generate them by writing code that's really similar to those really familiar paradigms you have when you're writing Angular or React components. So you can actually finally do the fable write once, use anywhere. And these components just work. So like I said, they're based on web components. And if you don't know what web components are, I'll give you just a very brief summary. I don't want to get too far into the weeds. They're basically a new feature in modern browsers. They were first proposed about 4 years ago, and they allow you to use custom HTML elements, just like the ones that you might create in Angular or React, but without needing Angular or React. And there are also polyfills, so that even in the older browsers you can use these too. Now you might be wondering, why not just use web components directly? Well, it can be a little bit of a hassle. It can be hard to understand the standards necessarily, so Stencil is a tool that just makes it simpler, it's more familiar, and it's performant out of the box. It does everything you need to do to have 100% standard compliant web components that you can reuse in different frameworks. So now I want to take a look at just the most simple possible Stencil JS component so that we can talk about how it works. This component is basically just going to display a name tag. So you can see that it uses this @component decorator to identify the tag as well as the location of the style file. So far, if you've used Angular, this should be really similar. You might even think that you're looking at Angular. But there's a couple of different things here. So there's these two other decorators, @prop and @state. These are two decorators that basically key into change detection for the component and will allow the component to re-render itself. So @prop, that means it's an input to the component. So it's just like in Angular, if you were to declare @input, it's an input that the component accepts, and if it gets a new value, it will re-render. And @state is similar, except it's private. So if you need to do some kind of calculation in the component, and you change an @state variable, then the component will re-render. Pretty simple. Now, how does it render? Well, we have this render function here, which is just going to return HTML. And so if you've used React, this is using JSX, which is a way of embedding HTML directly into your JavaScript. So it should be pretty simple to understand if you've used React. If not, like I said, it's basically just a way of embedding HTML in your JavaScript, and vice versa. Because as you can see here, you've got these HTML paragraph tags, and you're actually able to use some interpolation here to access that name property on the component. So there's no separate HTML file like you have in Angular. Instead, like I said, it's more similar to React. And there's a lot of other features in Stencil that I don't have time to completely get into. But just to summarize, they're very similar to any other modern framework. They have things like template references and lifecycle hooks and events. But what's really amazing is that this is not a framework. This is not something that you need to ship in your bundle with a compiler in order to interpret it. It's actually going to get compiled and then just be attached as a web component. And the way that's able to work is because the browser is actually the compiler for it. Because of this new standard of web components, the browser itself is what understands how to process the output of Stencil. So you don't need to ship your whole compiler along with it. So from here on out, if you've now created that Stencil component, all you need to do is build it using the Stencil command line. So after you've built it and you've published it somewhere, maybe to NPM, all you would then need to do is install it as an NPM package. This is one of the possible ways to use it. I'll get to a couple others in a moment. You could install it as an NPM package, and it just works. At that point, there might be 1 or 2 lines of configuration you need to do for different frameworks so that your project recognizes these components, but it's not actually in terms of compiling them. You know, Angular doesn't have to touch this, it just has to basically ignore it. Right? And this package will now immediately work in any framework. So that solves the first problem that I talked about, frameworks. Another great thing in terms of how you can use Stencil is you can actually bring it in as a script tag, which might make some of you guys think back to when you would use jQuery and you pull it in via a script tag. But why is this actually a really good thing? Why is this so great? It's actually great because, as you can see here, there's 2 script tags. We're doing 2 script tags here because Stencil has a feature known as differential loading, which means it's going to generate 2 different output targets. One is for older browsers, and one is for newer browsers. For newer browsers that have web components built into them, and you can think of that as the compiler for web components, since it's built in, it doesn't really need to include much. It can really just include some really tiny JavaScript files that represent these components you've built. For the older browsers, it's going to include some polyfills for you. So when you do this, you don't get both. What happens is the browser looks at this tag, and since it has no module, that means it needs to pull in the older version. So you don't need to actually ship the entire polyfill included artifact. You just need to add these script tags and let the browser decide which one to pull in. So that means that on a newer browser, I can optimize and just get a tiny bundle, and on the older browser, I'll get what I need, which is those polyfills to make this work with the web component standard. Once again, why is that great? Well, the second problem I talked about earlier was versioning. So since this gets pulled in at runtime now because it's a script, that means this package is always up to date. And if we use semantic versioning and however we're making this package available, then we can just make sure that anytime you refresh a page, you're immediately getting the latest version. I no longer have to go and update the package everywhere and recompile it and make sure it deploys. And I don't have to worry about any kind of dependencies because Stencil is not actually a peer dependency for the package that uses this Stencil component. Once you've processed your Stencil components, they can now be used anywhere. The other thing that uses these Stencil components doesn't even need to know Stencil exists. Just for comparison, here's some bundle sizes. So on the far right, this is an example of when we were pulling in the Angular pattern library. There's a lot of things going in there. When you're pulling in those Angular components, they still need to have a lot of information for Angular to actually be able to process them. With Stencil, it's much smaller. Like I said, the browser is taking care of it. On that third column here, you can see this is what it looks like with the polyfills. This is what the entire thing looks like if you're using NPM, so it'll still be pretty big, but not so bad. And then this is in that best case scenario when you're using the script tag and you're using a modern browser, so it doesn't even need to pull in polyfills at all. It's absolutely tiny. So just to wrap up, I want to show you a couple quotes, a couple testimonials from our developers who worked on this as well with me at a recent Hack Week. It's somebody who said that it felt really familiar to Angular, the syntax is really similar, it's really polished and complete for a first version, and lastly, it's killer out of the box, it's very easy to set up, it has a great CI tool, and everything worked. Okay, so it might sound like a lot of hype, but I've found it to be a really pleasant development experience. I found it to solve a lot of big problems And there's a reason for that, and that's because this is based on the Web Component Standard, which was in the works for like 4 or 5 years, and it's finally gaining support. And now that it's actually here, it's kind of a new, small but important paradigm in web development. So hopefully you learned a little bit today about how this can actually be used. So does this actually solve the 2 problems that I talked about, right? Frameworks and versioning. Frameworks, yes, of course. These are web components. They can be used anywhere. Once I've included it, all I need to do is put that component tag on the page and it just works. And versioning, yes. With those script tags, you could avoid versioning if you use some semantic naming for where those resources are. As long as it's something reasonable, you don't need to actually do any updating of the consumer packages anymore. Things will just get pulled in up to date. And the developer experience, as mentioned by those 3 people I just showed, is really good. The command line tool is perfect. It gives you everything you need. It's a very small dev server. It's easy to test. So basically, my message for you guys here today is if you've ever experienced a lot of these problems that we have with component libraries, hopefully you think about trying Stencil. Go take a look at it. It has pretty good documentation online. And I open the floor for Q&A now, and thank you very much.
So I got a question.
Yeah.
Is it good for only small components, or can you do like bigger stuff like, I don't know, models, for example, selects or things like that?
Yeah. So if we're talking about modals, it would be good for modals because it actually has the ability to accept like an inner element. So you could actually read in some inner data. In Angular, you would call that a template variable. So you can actually read in a template, something like that, and then it can just get rendered inside. So for a modal, all you would need to do is leave that inner space available, make sure that the component knows how to handle it, and then you could do all of the behavior and styles related to launching the modal. So it would handle at least that part of it, and it could be simply reused. And once again, our use case was UX, right? So we're not necessarily concerned with entire pieces of functionality, entire features. We're mostly concerned with atomic things, like little atoms that can be reused across applications. But if you did want to make bigger things, one example that I have for you is that one of the results from working on this in our recent Hack Week was that an important problem we needed to solve is the fact that one of those components that needed to be shared across all of these applications was a header. And that header is actually pretty complicated because it needs to pull in data about who is the user, so they can display the user in the top. We didn't want every app to have to do that themselves, things like that. So we actually used Stencil to create a component that was more of a micro front end, if you're familiar with that concept. So it's kind of as if we were using an iframe across the top, but instead we were pulling in this Stencil component, named it header, whatever, and just telling our consumers to put it at the top of the page. And inside, it was just doing some really simple work with the fetch API in order to pull in the data response, who is the user, and render all of that. So yes, you can do more complicated things if you want as well. Any questions?
But why there is no problem with versioning if you put the script tag? If you put the script tag, you put the version in the script tag.
Yeah.
Because otherwise it will be cached forever, or like it will be, you're not caching it, then you lose some performance on first load or whatever. So how it solves that? Because there could be a breaking change introduced anyway, even in the simplest thing.
Sure. Yeah, there could be. So there's a couple of different points that you brought up. So it automatically hashes all the assets. So if the assets actually do change, you'll be able to pull them in properly. So that part, the caching, that's handled. In terms of using the versioning, so you could think of a more simple versioning scheme where you're only doing, say, major versions that actually cause breaking. So then all you would have to do is go through these different components and just change that, that one file if you wanted to pull in some of the newer components. But in terms of the things you were already using, you could ensure that they're always up to date. And then anything that's breaking, you would just do a major version, so you wouldn't have any breaking changes.
Yeah, but it's semantic versioning. It's like you can do the same thing in React, so I just don't understand the benefit at the end. Anyway, but Okay.
Well, so the benefit is that if you're using a semantic version system that is more flexible, right? So if you're saying you can take any minor version and any patch number, then as soon as you refresh, you've got the newest package. So any more questions?
But what size of the components you have? Because I mean, for button, it's okay to wrap it up, make it the same style. That's it.
Yeah.
For something else, but you for sure gonna have some special API of these small things, and this is kind of, I mean, like you need to know the stencil, you need to know these props, and then you need to stick it together with React, for example. I don't know. For me, it feels like a lot of overhead anyway. Just I don't know. Maybe it's not, but
So I think the idea of having a component library is going to incur overhead for sure. Hopefully, it's also solving some problems in exchange. But really, what I'm talking about is migrating from Angular pattern library as an implementation to Stencil, and why that solves a lot of problems. So hopefully that comes across. But in terms of component design and architecture, there's absolutely room to make architectural mistakes. I'm kind of intending this to mostly be for pretty small atoms to start with, and maybe we'll come across more of those rough edges, but it's working for us so far.
Yeah. What about testing? How you test?
So Stencil, it comes with just packaged in, so it's very simple. And since these are actually just JavaScript components, you can just declare them the same way you do with React. You can just say new component, and you can do component-based testing. Where if you want, you could actually use a solution like Puppeteer maybe, and you could actually just put it on a dummy page and then do some UI interactive testing.
Okay. So are the resulting components typed in a way, like for example, if you use them in React?
Yeah, the part of what Stencil does is it automatically generates the typing files for these components as well. So if that gets imported, if you're using it as a script or an npm package, you'll have the typing.
Polymer is a web component library also, right? It's from Google. Actually, more people relate to Google. I don't know who stands for the Stencil JS, like which company. And I would say more people relate to Polymer. Have you had the chance to compare them?
I don't have a ton of hands-on experience with Polymer, but I've heard some people like it, some people don't like it. I'm sure as it becomes more mature, it'll also be just as good, if not better. But this is one option. There's more options, but it's more about the problems it solves than specifically. Okay, I'm just going to stop it here. So if you guys have any more questions, feel free to get some more food. Come talk to me, come talk to Rafał. And thank you guys very much for coming.